Hello everyone, I'm Paul and today we're solving problem 2561, rearranging fruits. This is a hard one, but the logic is simple, so next I will show you how to solve this efficiently step by step. There are two baskets containing fruits, and we are given two integer arrays, basket 1 and basket 2, where each element represents the cost of each fruit in each basket. And this is our job. We need to return the minimum cost to make both baskets equal or -1 if it's impossible. And in order to do this, we can use this operation as many times as we want. We can swap fruits from different baskets, and the cost for this swap is the minimum value among the cost of these fruits. Let's say we have these baskets. Here we can already see that it's impossible to make these baskets equal. And why? Well, because we have only 1 7 and 1 5. So we have the first observation here. If we find any odd frequency, we return -1, meaning it's impossible to make these baskets equal. Here we are seeing number 7 only one time and number 5 only one time, and 1 is odd, so we return -1. So now the question is, how can we get the frequency for every element in these baskets? And the answer is we can use a frequency map. So now let's say we have these baskets and we are creating a frequency map, and we are storing the count for each element in the form of delta. This means we are adding counts in the first basket and we are subtracting counts in the second basket. This is how we can get the difference for every element, and this is how we know which are the elements we need to swap. So we create an empty map, and first we are checking these frequencies. So here we see number 1, 2 3s, and 1 5. And remember, here we are adding the counts and here we are subtracting the counts. So now we are adding these frequencies, subtracting counts in the map. Here we have a 1, so we subtract 1 here, this is now 0. We have 2 4s and we are subtracting, so we have a 4 with a count of -2. And we have a 5, remember we are subtracting, so 1 minus 1 is 0. So this is our final delta frequency map, or whatever you want to call this. Here we know which are the elements we need to swap. For example, 1 is 0, meaning this is balanced, so we can forget about this. We have a 1 here and a 1 here, so this is okay. The same happens with 5. We have a 5 here and a 5 here. And 3 and 4 are not balanced. We have 2 3s here, that's why this is 2, and we have 2 4s here, that's why this is -2. So we need to swap these two elements, and the amount of elements we need to swap for each of these is the absolute count, in this case 2, divided by 2. So we need to swap one element only. Why? Well, because here we have two elements. If we move these two elements down here, now we don't have any more 3s up here, but we need to keep 1 3. This is why we need to divide the count by 2, and the result is the amount of 3s we need to swap. And the same happens here in 4. We have 2 4s here, meaning we need to move 1 4 up here. So we take the absolute value for this count, meaning 2, and divide this by 2, and this is 1, meaning we need to move 1 4 up here. And now the key observation for this problem is the following. We know we have to swap 1 3 and 1 4. And we have two ways to swap each of these. For example, we can swap 3 with 1, and the cost for this swap is 1. Or we can swap this 3 with the other element we need to swap, meaning 4, and the cost for this is 3. And the same happens with 4. Obviously, we can swap 4 with 1, and by doing this we have a cost of 1, or we can swap 4 with 3 with a cost of 3. And remember, we need to return the minimum cost to make both baskets equal. So first we are putting every element we need to swap in an array. So this array contains every element we need to swap. We need to swap 1 3 and 1 4. If we had 2 3s, for example, this would be 3 3 4. Okay? And we are iterating this array from left to right, from index 0 up to half the length of the array. The result is initially 0, and each time we are taking the minimum value among the current value 3 and 2 times the minimum value in these 2 baskets, meaning 1. And the result for this is 2. So the result is 2 up to this moment. And remember what this represents. 3 means we are swapping these and these values. And 2 times 1 means we are swapping 3 with 1, and then we have 2 1s up here, so this would be a 1. Then we are swapping 4 with 1 with the cost of 1 also. So finally we'll have 4 and 3. So in this case it's more convenient to take this strategy. That's why result is 2 right now. And we are sorting this and iterating only the first half of the array, because if we also iterate this, we are repeating work. Remember, here we are already considering the cost of moving these 4 up here. So now we update the pointer, we reach the end, and we return the result, which is 2 in this case. Let's go with another example just to make this clear. Let's say we have these 2 baskets and we are repeating the same process. First, we are adding this to our frequency map. So we have a 3 with a count of 2 and 5 with a count of 1. And remember, we are storing these as delta values. So now we are adding this to the same map, but we are storing every count as -1. We have 2 4s, so we have 4 with a count of -2. And we have 1 5, so we subtract 1 here, this is 0. We know this is balanced. Here we have 2 5s, and we need to swap 2 divided by 2 3s, meaning 1, and 2 divided by 2 4s, meaning 1. So now we are putting this in an array, and now we are iterating this up to half the size of this array. So we are here, and the result is the minimum among 3 and 2 times the minimum value in these 2 baskets, meaning 3. And 2 times 3 is 6. So the result for this is 3, meaning we put a 3 in the result. We update the pointer, we reach the end, and we return the result, which is 3. And what this 3 represents is we are swapping these and these elements. We are going with the first strategy. So this is it for the approach. Time complexity will be big O of n log n. Remember, we need to sort this array with the elements we need to swap. And space complexity will be big O of n. So now let's go with the code, and hopefully you will get the idea. First we say n is the length of basket 1. Remember, these 2 baskets have the same length. Frequency is initially a default dictionary with a default value of 0 for every key. That's why here we use the word int. The minimum value will be initially infinity. We use infinity like this in Python. And now we can build our delta frequency map or frequency map with delta values for every count. So for I in range n, frequency for basket 1i plus equal 1, and frequency for basket 2i minus equal 1. And the minimum will be the minimum among the current value and basket 1i, basket 2i. So now we can create an array to store the elements we need to swap. So we'll call this to swap. This is initially an empty array, and now we can iterate the map. So for every key and value in frequency.items if the current value modulo 2 is different from 0, meaning it's odd, we return -1 right away. This means we will never be able to build two baskets that are equal. Else, we say to swap plus equal an array with the current key times the absolute value divided by 2. And this is exactly the same we saw a few minutes ago in the drawing. And now we can sort this array to swap, so to swap.sort, and the result will be 0 initially, and now we can iterate to swap, and we are iterating only the first half. So for I in range length to swap divided by 2, result plus equal the minimum among to swap I and 2 times the minimum value. And remember, this minimum value is this minimum value, meaning it's the minimum value among these two baskets. And this is our first strategy. Here we are swapping one element in the first half of this array with another element from the second half directly. And this is our second strategy. Here we are swapping the current element and the corresponding element from the second half of this array with the minimum value among both baskets. So we keep the minimum value among these two and we add this to the result. And finally, we return the result. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.